I think we can start. This is the networking, NFVs and SDN workshop, and I'm going to take most of the part of the workshop, although we have some presentations included in this session, right? So what we're going to see today is I'm going to go through a brief review of the OpenNebula network stack. We are going to review what it's in OpenNebula, basic networking things and so on, and I'll take it from there to go deeper in the networking drivers. So we'll do some hacking or look to the low-level details of the drivers, and I will try to review a couple of new features. We have the virtual routers and EPAM drivers, and at the end we have a couple of use cases. The first one is a brief description of OnLive project and how OpenNebula was integrated with ONOS, and the last one is Beacon that will show how we can build an federated network across different sites, right? Okay, so let's start. This is I want it to be somehow a casual session. So if you have a question or want to stop to discuss anything, just raise your hand and we can stop and talk about that. So it's we prefer wanted this to be an open session or a session where we can easily discuss things, right? Okay, so let's start with the networking stack. This is more or less our view of networking in OpenNebula. So basically what we have in a data center right now is switching or routing fabric where you have your core backbone network, right? This can be leaf spine interconnected switches, or sometimes you just have top of the rack switches in your data center. It comes in many flavors, but basically we assume that there is an underneath backbone network in your data center, right? We are going to talk more about SDNs in the future, but we see this backbone network as the classical target for the SDN. So OpenNebula is not going to do anything at that level apart from integrating with an SDN component, right? Then we have the hypervisors, which are the nodes where we run VMs, and usually we have a kind of virtual switching within the hypervisors. These virtual switches are used to interconnect virtual machines to this interconnection fabric in the data center, right? OpenNebula take care of these virtual switches by creating them, tagging the interfaces to implement VLANs and so on. And the virtual machines is in the layer, which is composed by the virtual machines and the virtual network implemented using the virtual and physical switches in your data center, right? So OpenNebula do a couple of things here, like providing the virtual machines with the networking context needed to configure the network for the VMs, right? So this is more or less the big picture where we are going to dive in this session, right? Okay, so this is our view of the network. How is the networking features provided by OpenNebula? We have, I will say, like a built-in SDN, something like a specialized component that provides a central point to define and manage virtual networks for virtual machines. It's a special component designed to only for virtual machines, right? As another SDN, we have like a northbound interface where you define virtual networks, where you define addresses or any logical addresses paired for VMs. You can make reservations. You can implement provisioning policies or listing policies of IP addresses. You can impose quotas and that kind of things, right? And then we have a southbound interface to talk to the network elements. In our case, these network elements are basically the infrastructure provided by the hypervisors, or an SDN, as we're going to see at the end of the session, where we can interact with to define which virtual machines are running in which hypervisor, so the SDN can create paths across the switching fabric to reach or to send traffic to the VMs, right? So we are going to start by reviewing quickly this northbound interface, and then we'll be talking about this southbound interface in OpenNebula, right? Okay, so the northbound interface, how we define networks in OpenNebula. So basically you have two different parts here. You have the logical address space or attributes that compose the network, and some physical or implementation details to implement the network, right? So in the logical part, we have the address space, where you define multiple address ranges, like sets of IPv4 addresses or IPv6 addresses or MAC addresses for your virtual machines. So when you create a virtual machine, it's going to take one of these addresses for their interfaces. You can also define security groups to impose filtering rules in the virtual machines. Those are managed as a separate entity, so you can list your security groups, create new ones, and once they are created, you can attach them to the virtual networks to define filtering rules for inbound traffic, outbound traffic in different protocols, ports, what you commonly expect from a security group. And then you can put custom tags, right? That's for the logical attributes. In the implementation part, we have new in 5.2 or 5.0, we have the driver, which is going to implement the network. And the driver is we are going to see the set of specific actions that take care of implementing a network in OpenNebula, right? And then you have also a specific configuration attributes for the driver or for the network, for example, which is the VLAN ID that you are going to use, or which is the physical device that the network is going to use, or the bridge, or whatever, right? This VLAN ID, we've been also working on that in the last release. Now, OpenNebula controls across all the software stack which VLAN IDs are used, and if they are automatically generated, that is preserved at the driver level, right? So we work in this VLAN ID generation a little bit in the last release. And also you have VM context attributes. So when you define a network, you define the addresses, you define how the network is going to be implemented, and you can define configuration attributes for the VMs in that network. For example, you can define the DNS server for the network. You can define the gateway for the network. So when the VM boots up, it can get the information for so the configuration information for the network from the context and configure automatically using the context packages, right? So some tips when you define your networks. The first thing is that a network can be a set of different address ranges, right? So you can define your network as a logical supernet, right? So you, for example, have like the notion of a public network in my data center. This public network can be implemented by different address ranges. Each address range can have a different set of address spaces, can have a different set of configuration attributes, and even they can be implemented in different ways. But you can glue them together to form a logical entity and manage the logical entity together, for example, for access control or for implementation at the cluster or associated it for one cluster or another, right? Sometimes you need to take IPs from a range. You can either do different address ranges to skip the gaps, or you can put these addresses on hold. So you, for example, in your network, the .001 address is reserved for the gateway, and you don't want that to be assigned to any IP. you can define that in your address range, but you can put on hold that list, so it's not going to be assigned to any virtual machine. But also, sometimes you really need to give those addresses to virtual machines, but you don't want to every people be able to get those addresses. For that situation, for example, you can use a reservation. You can make a reservation from a network, which will create another network with IPs from the original network, and you can use that reservation for special purposes. For example, I'm going to take a given set of IPs from a network, and those IPs are going for the servers or services in my network, for example, for the DNS or DHCP or whatever well-known IP addresses that I need in a network. Putting that in a reservation prevents users or other VMs from taking those IPs, so you can control how those IPs are assigned, right? And then you can use labels. Those are new in 5.2, and if you are using Sandstone a lot to organize your networks, that it's really coming handy in those situations. So, for example, here I'm going to use this setup through the examples. I have here a simple cloud which is running on two. This is here. I have two nodes which I'm going to enable in order to execute the virtual machines. So I have two simple nodes, and we are going to do networking things on this node. So I have prepared a couple of virtual networks to perform some examples. As I said, you can use labels. For example, these are the infrastructure networks. So this network is used to interconnect the hypervisor, for example. Then I have my virtual networks. I have two virtual networks that we are going to use. It's the red virtual network and the blue one. And let's take a look to one of these. Here you have the information. For example, the address ranges. This, as we said, define the set of IPs that are going to be used in this network. In this case, I have one address range from 55200 with 3 different IPs. You can see how many IPs are actually linked to things. In this case, I have 10 IPs linked to virtual network number 3. You are going to see this when the networks are reservations. So here you can see which VMs or reservations are using IPs from this network, right? So this means that 10.5.5.200 is in use by network 3. Okay. Here I have a security group, which is VM traffic. I'm going to talk about security groups later. And the virtual routers associated to this network, known right now, and the clusters where this network is attached to, which is in the KVM cluster, right? If you take a look to the info panel, here you can see all the configuration attributes for the network. So, for example, in this case, we are using the ENS3 interface as the physical device to implement the network. The VLAN ID is 200, and we are using the VXLAN driver. Okay, so those are the configuration attributes for the network. And also here you see the context attributes. So, for example, the gateway is 255.200 or the DNS 10.551. What this means that when you create a virtual machine attached to this network, the virtual machine is going to get all these attributes in this context information. So when the virtual machine boots up, it can configure its DNS or gateway to point to those IPs. Okay, when all of these values can be override with an address range. When you create an address range, you can define if it's going to be IPv4, IPv6, the IPs in the range. But if you take a look here, you can override any value from the network. So for example, an address range can have a different VLAN ID than the original network. Or you can have a different DNS for a given set of IPs in the network. So it depends. So what I want you to see is that you have quite a flexibility to define how your networking is going to be. And you can group all these networks under a single logical entity in a single network or virtual network, right? So in this case, here I'm going to use the virtual network red to start VMs, but I wanted some special VMs to have special IPs. What I've done is to create a reservation from this network. For example, in this case, I have the virtual network number 3. This is a reservation from virtual network red. I made the reservation, so I have this network is a network itself. You can use it as any other network, but it has a subset of the IP addresses of the original network. I've done that because I don't want to put for example, the 200 IP on hold, because I wanted to assign that to a virtual machine. So what I've done is I create the services red virtual network to put special VMs in that network. But I want to control the same, or I want to have a unique control point for the IP addresses in that network. So I made a reservation instead of creating a new network, right? So I think that's very useful. So if you take a look to the services, I have 2 special networks which are reservations. You can see that here, which say yes, this is a reservation from the original blue and red services. Okay? So this what I'm going to use, and I wanted to show you because it's a good excuse to review all the networking stuff or basic networking stuff in OpenNebula. So any questions till now? Okay. Sometimes people want to put the IPs on hold, but if you do that, you cannot assign that to a VM. So you cannot hold an IP in order to later assign it to a VM. So it's better to have a different network. So in that case, making a reservation, it's really the way to go. Note that this reservation, you can have different access control for the reservation. You can have different ownership in the reservation, so different people can access different parts of the address space, right? Also new in the 5 version is the topology. If you take a look to the network topology, here you can see the networks defined in OpenNebula. So we have the management network with the 2 hypervisors that we are going to use, and these are the virtual networks for the VMs, right? As you can see, reservations are not shown separate in this topology graph. So the blue reservation and the red reservation are consolidated in just one network, right? Okay, so let's move on. Let's talk about the drivers. So far we've reviewed how the network is defined. We can define the address space, how the network is going to be implemented, but how is this network actually implemented in the hypervisor? This is done by or with the networking drivers. So these are the stock network drivers in OpenNebula. We have like 3 different sets or 4 different sets. There are a couple of drivers based on Linux bridging, the standard kernel Linux bridging in the host. Here you have VLAN tagging, you have plain or bridge networking, you have VXLAN, and you have EV tables. So all these three, VXLAN, EV tables, and VLAN tagging are used to create VLANs. So basically we create the interfaces, bridges, and tag the corresponding interface. The bridge networking is just to interconnect to the VM for an existing bridge in the host. So if you have special requirements and you have preset the networking interfaces in your hypervisors, you can use bridge networking. And on top of that, we have the security group extension. So based in IP tables, we implement these security groups for these form bridging or networking modes, right? Then we have OpenVSwitch that can work in bridge mode or VLAN. Bridge is to attach the virtual machine to an existing OpenVSwitch in your hypervisors. And if you are using VLAN, we also tag the OpenVSwitch ports with the associated VLAN ID. In this case, with OpenVSwitch, you cannot use security groups, right? Why? Because our implementation of security groups is based in IP tables, and OpenVSwitch is not compatible with IP tables. In previous versions of OpenVSwitch, you can use OpenVSwitch in a compatibility mode, so it's basically a bridge or a Linux bridge, or can be interfaced by the kernel like a Linux bridge. You can do that or still do that in OpenNebula. We have the drivers, but the preferred way is not doing that way. And with the problem to not implement these security groups is that the filtering rules in OpenFlow are not as flexible as the ones you can express with IP tables. So there are some filtering that we can do, for example, for MAC spoofing and those things, but the complete functionality exposed by security groups cannot be implemented right now with OpenFlow in OpenVSwitch. Then we have the virtual router, which are not the specific drivers, but are the NFV that you can use to interconnect networks in OpenNebula. And in 5.2, we have a new set of drivers, which are the IP address management drivers. So right now, when a virtual machine is created, OpenNebula is in charge of check which IP addresses are free and assign the IP address to the virtual machine. But sometimes, especially in big deployments, the IP address is managed by another team in the company, or by a separate software component. So in order to make OpenNebula compatible with those deployments, we have now the IPAM drivers, the PAM drivers. So when OpenNebula needs an IP for the VM, it's able to contact to an external component for the IP and assign the IP to the virtual machine in the traditional way for OpenNebula. This is through the context and so on. But the good thing is that, or the new thing is that you can use an external component for IP address management. How this is implemented? We have like 3 hook points, pre, post, and clean, which are executed right before the VM is boot, after the VM is boot, and when the VM is shut down. So in the pre-script, you basically or typically create bridges or prepare tags for the virtual machine. Then you create the virtual machine attached to the interfaces you have created. And in the post phase, you install, for example, firewall rules, or do post installation things that are needed or that need to be done when the interfaces are up and running. And clean is, as its name says, for cleaning up things. There is a new operation in 5.2, which is update SG, which is called whenever a security group is changing the VM. So when you change the security group associated to a VM, and a special driver action is called to update the security group. So if you need to hook there, all the drivers have that operation also. And I say that it considers live migrations because the pre, post, and clean are executed in that order in the host. So when you're moving a virtual machine from a host to another, the post is executed when the virtual machine leaves the original hypervisor, and the pre is executed before the virtual machine is moved to the next hypervisor. So live migrations are considering these pre, post, and clean executions, right? Okay, so before going here, let's start a couple of PMs and let's see what happens. Okay, so to show how these things works, we are going to start a couple of PMs. So I have prepared, I have a couple of templates based in Alpine Linux. So I'm going to instantiate one virtual machine. This one is going to be attached to the red virtual network. Okay. Let me put his name, and let's create another one. This is the PM blue, and I'm going to put that virtual machine in the blue network. Here, as you can see, you can request a specific IP from that network. You can customize the security groups that are going to be used by this interface in that network. If you do not do anything, the defaults from the virtual network are used, right? Okay, so let's create this one. So here I'm going to show you just the virtual machine. So I picked my virtual label, and right now I have one of the VMs running. Let's see the networking things, or networking part of the VM. The first one is the virtual interfaces of the VM. So here you can see the IP address that the VM is received, the virtual network where this networking interface is attached to, MAC addresses, and you can get more details. For example, in this case, the security groups that were used to start the virtual machine. Right now I have a dummy security group because I want to play with it in a few minutes, which is the VM traffic. And now it allows all outbound and inbound traffic in both directions, right? And here you have some metrics obtained from the hypervisor in terms of how many bytes has been received and transmitted for the virtual machine in that interface, right? Let's see, for example, one virtual machine. I don't know if you can, probably you are not able to see this. Oh, let me try. But if you can see, for example, you see that the main interface of the virtual machine has been configured with the 10.3.3 to 10 IP assigned from OpenNebula. How has been this configured? This has been configured through the contextualization scripts, right? Context is information that is passed to the virtual machine when the virtual machine boots. So in this case, I'm going to leave this here. So if you take a look to this virtual machine with this IP, and take a look to the template, this information is sent to the virtual machine when you create the virtual machine. So for example, in this case, the IP address is passed here, but as you can see, the DNS or gateway is also passed to the VM. So the VM can configure its DNS or can configure its gateway based on this information. And this information is the IPs we set up when we define the network. So from the network console, let's say that way, you can define which IPs are going to be using as gateway or DNS or DNS domains to search or any other thing that you want to configure through the network. So in this case, the virtual machine is not using, for example, DHCP to configure its networking. You can pass also, for example, the public key for the root user, so you can log in the virtual machine and so on, right? Okay, so obviously, although this if you try to reach one of the virtual machines from the other, like for example, you try to ping the other virtual machine, you can do that because they are in separate networks. They are in separate VXLAN networks, so they cannot see each other, right? So what really happens in the hypervisors to set up these things? So if we take a look to the process, let's go to, for example, here. When we created the virtual machine, the drivers created a couple of things. It created a special VXLAN interface, which is ENS3.100. It created a bridge, which is this one. And in order to link the virtual machine to the switching fabric with a given driver. If you take a look to the, for example, the tag interface which the virtual machine is using, this is a VXLAN interface with VLAN ID 100. Here you have the multicast group for the VXLAN interface, which is going to use to broadcasting traffic for ARP and the like. You have the UDP port that is going to use. All of these things can be configured when you configure the VXLAN driver. For example, if you take a look to the MTU, this is not the 1500, the typical 1500. It's reduced in order to consider the encapsulation overhead. All of this can be, or it's configured by the drivers and can be configured through the configuration files of the drivers. Apart from creating that interface, the drivers also create the bridge, this one, to attach the VXLAN interface to forward traffic outside the hypervisor, and in this case, the network interface of the virtual machine. If you take a look to the names, they have well-known names, so you can hook easily, or if you need to do administration tasks at the hypervisor, it's easy to identify which VMs are attached to which interface, because this corresponds to the VM ID. This is the virtual machine 20 in OpenNebula, and this corresponds to the network interface. So this is the first interface of the virtual machines 20. Also, when we tag an interface, we use the common convention of putting the VLAN ID after the interface name, and the same thing for the bridge. Here you see this is the OpenNebula bridge associated to the VLAN 100, right? So it's easy to look for a given interface if something goes wrong, or you need to debug your networking traffic somehow. It's easy to take a look to where everything is being set up. Okay. So any questions so far? You want to take a look to no? Cool. If you take a look to the drivers, this I extracted the most important part for the VXLAN driver, and what is happening in the VXLAN driver, if you need to hook in and put your own customizations, this is basically the operation. You get the deploy ID of the VM and the VM template encoded in base 64. And with that, you have all the information needed to create the network, right? So you get all the information from each network interface of the VM, where you have the bridge, the driver that is going to be used, and all the configuration needed to set up the network. So from that VM template, you basically activate the interface. And this is the code for the driver. In this case, you generate the VLAN name or the VM interface name. You create a bridge, which basically is this command. You create the tag interface, which basically is a new IP link add command. And then you attach the tagged interface to the bridge you have created. So this is happening before, in the pre-step, or before creating the VM. So when you boot the VM is going to be attached to this bridge, and it's going to use this VXLAN encapsulation all the way in the networking, right? If you need to change anything in your drivers, just remember that those are defined in the remotes. So for each driver, you have a directory, in this case VXLAN, and in that directory, you have a script or program for each operation: clean, post, pre, and update security group. So if you need to change or customize the process, here you can change anything. This is, in this case, this is Ruby code, but can be anything you are used to. It can be Python, can be Bash, can be anything, right? If you change something, don't forget to run the one host sync script, which synchronize changes with the host, right? Because those scripts are executed remotely in the hypervisor. So you changes something in the front end, you have to synchronize the changes to the hypervisors. The synchronization is based on the version control. So if you take a look to one of the hosts, for example, KVM1. Here you have a version number. This is the version number for the drivers used. If you want this process to happen automatically, you have to increase the version number in the drivers directory, which is up here. So if you increase the version number, then and synchronize the drivers are going to be copied to the hypervisor. This is done because probably you have different versions in different hypervisors, or have different clusters with different versions of the probes and that kind of thing. So sometimes it's useful to have this versioning. If you don't want to increase the version number, you can force the update. Sorry. And it will copy it anyway, right? Okay. So this is a scheme of what is being done for the VXLAN driver. As we've seen, we use a base physical device, which is the main hypervisor interface. If you are going to use VXLAN, remember that you have to put an IP in this interface because all the traffic is going to be encapsulated through this IP. So in the communication is hypervisor to hypervisor using the hypervisor IPs, not the VM's IPs. So don't forget to do that. Also, you can put that traffic in a special VLAN. So this can be a tagged interface with VLAN tagging if you want to isolate the hypervisor traffic for the VMs, for example. And this is more or less the structure within the hypervisor. A bridge for the VXLAN encapsulation with a multicast group associated to this interface. By default, we are using the 239 multicast group with the VLAN ID for the multicast address. So the VXLAN with VLAN ID 100 is going to have the 239-100 multicast group. We have a bridge associated to this VLAN, and all the VMs in that VLAN, in that hypervisor, are going to be attached to this bridge. It's important to not to, if you have different VLANs, not to somehow link the bridges. We've seen that a couple of times because the VXLAN traffic is going to mix, right? This, as we've seen, is what happens when you execute the pre-operation, and it's clean when you shut down the virtual machine, right? Okay. So any questions?
Most folks use the MTU, or do you have any kind of confidence, or are there any problems to expect if you were to use jumbo frames?
We do that in the driver. I mean, you can set up the MTU for the interface. So when this interface is created, the MTU is reduced. Yes, you can do that. Yeah. So in this case, it's part of the configuration. But if you take a look to the VXLAN driver, what is happening in backstage is quite simple. So basically, what we are doing is creating the interface, and for example, here you can, if the MTU is defined, you use that. If not, you can leave it there, and you can change whatever you want. For example, the TTL, which is sometimes for VXLAN is needed to set up to integrate it with the network, anything. And if, for example, if you want to activate the RP proxy in the latest versions of the kernel, they have that for VXLAN. You can just change this command, even if it's not exposed in OpenNebula. So the message is that those are really simple scripts. I mean, we have the logic to pass all the information down, but at the end, it's a simple command. So if you need to change that, it's easy to do it. Okay. This case is Ruby, but sometimes it's just simple Bash scripts. Okay. So anything else for this? No? Cool. So far, we have reviewed the OpenNebula network model. We have learned how to define networks, how IPs and reservation works, and how that information is passed to the VMs to configure the VMs. Then we've seen how those virtual networks are implemented. So we've reviewed these 3-step setup, pre, post, and clean, and basically what is needed in when you create a standard VLAN for the virtual machines. So the next thing we want to do is review some of the new features in 5.2. We are going to start with virtual routers. So this is a 5.0 feature. What's the idea? The idea is that, okay, I know how to create a virtual network, I know how to implement it, but sometimes I need to route traffic between two different virtual networks because I want to interconnect them, because they are implemented with different technologies. For example, here I have a classic VLAN tagging network, and here I have a VXLAN network, because I want to give more networking services to the network. I want to implement DNS, or I want to implement DHCP in a network. I can put more networking functions in this component. So to implement that, or to do that, we developed the virtual routers. These are first entity. In OpenNebula, you can create a virtual router, define a virtual router, manage the life cycle of the virtual router as a different or as its own entity. At the end, it's implemented with a virtual machine, but you have all the facilities to define, set, and control the virtual routers, right? So you have special views in Sandstone, you have a specific command line interface, even you have special control access for the virtual routers. They are a different entity. So for example, you can give your VDCs the ability to put or remove virtual routers from the virtual data center. So the virtual data center admin can route traffic between networks if they want to. As I said, this is implemented with virtual machine, and in the 5.0 release, this virtual machine is based in Alpine Linux. You can download that image from the marketplace. Has been pre-configured with HI, so we are using Keep Alive to have a cluster of virtual routers. So if one of these virtual routers goes down, the other can take the routing responsibilities for the down virtual router. And we also add support for reconfiguration. So for example, you can add more networks to route traffic across them, or detach networks from the virtual router. So you can, if you want to stop routing traffic to a given network, just detach the network interface for the routing. Or if you want to route traffic to another network, you can just attach it. Okay? So what we are going to do is to, we have right now two we have two different isolated networks, blue and red, and we want to start routing traffic between the two. So we are going to create a virtual router to route the traffic between these two guys. Let's go to, I have prepared a template for this example. This is a classical VM template, so you can customize or you can fine-tune the implementation of this virtual machine. In this case, it's going to be based in OpenWRT image, which is quite light. And the memory footprint for this router is quite low. these images are prepared for context, so you can pass your SSH keys. You can do anything you can do with a virtual machine OpenNebula. You can do it in the virtual router. So let's create a new router between red and blue. If you are going to use Keep Alive, you can put the Keep Alive password and the service ID, but we are not going to do that. And then you have to pick which networks are you going to be routing traffic between. So I'm going to route traffic between blue and red, but I'm going to pick the IP from the services blue, right? Why? Because I want the virtual router to have a specific IP, the gateway for that network. So that IP has been reserved from the main blue network, so you can assign special VMs or those IPs can be assigned to special VMs, right? As in the virtual machines, this can be customized, so you can apply specific security groups. You can specify this interface with a floating IP if there's going to be several routers in this network. You can specify this as a management interface, so you don't want to route traffic to the management interface. You just want to give this interface to connect to the virtual router and do management things. You can specify a given IP for the router, and so on, right? So everything you can define for a virtual network interface, you can do it for the virtual network interface of the virtual routers. I'm going to add another one associated to the network red. Again, I'm going to use the services part of the network because I want a special IP, and that's it. I can create more than one instance. The floating IP is that here. If you are using 3, yeah, it's for the so the virtual machines in this network are going to use the floating IP as gateway, but each router is going to have their own IP in this network, and you are going to float the IP for in case of failure. No, we are thinking of extending that. The idea is that you can lease an IP which is not really associated to a virtual machine. That's what we need to implement this. Yeah. One of the ideas we have for this is to generalize the routers, to have a cluster service, which can be a router or can be any clustering service. We can need floating IPs, and you can include more than one instance in the service and that kind of things, which has pretty much the same structure that one. Okay, so yes, that's an idea that we have for the future versions. Okay, so I think we have everything, and we can start the virtual router. So if we take a look to the instances, we have a new one, which is the red-blue router. Here you have a list of interfaces. In this case, I'm not using a floating IP because it's just one instance of the service. And these are the virtual machines that are being used to implement the virtual router, right? So if you go to the VMs instances, you also see this instance which corresponds to the routing, right? So as you see, it's using 2 different IPs, one in each network, and I made this reservation because if you remember, if you go to one of these VMs here, these VMs are using the 200 IP as a gateway. So I wanted my virtual router to have that IP in the network to be the routing for default gateway for the network, right? So this match with the default routing. Okay, so let's see if it seems that it started. Okay, so, well, this should be working. It's, let's see if we can go to the, okay. Okay. So it seems that this one is not working. Let me check a few seconds for. So what? I don't know why this. Let me review it. No, it seems that it got the wrong IP and. So I'm reviewing it because it should be configured with this IP, and somehow it didn't get the right IP. Let me just review it, and if it doesn't get the right IP, I will just change it and see if the router works. I don't know. Because the image is just the same, so. Delete. Default. Okay. Okay. It was sorry. sorry, yeah. Yeah, you're right. Let me see if I can ping the, okay. Let's see. Okay, so somehow the context for that virtual machine didn't work, I don't know why. But now we have traffic between these different networks, which are two different VXLANs with two different VXLANs ID, right? So this is more or less the idea of the virtual routers. You take a look to the topology. What we basically did was to add a virtual machine connected to these two virtual networks, and so the traffic from this network can go to the other virtual machine, right? Okay, so if you want to implement that, sometimes it's as is, it's enough for medium traffic or low traffic networks, but sometimes you want to implement with the virtual machines a networking function which requires performance. If you do that, you need to virtualize network functions which requires really performance. There are a couple of tips that you need to consider. The first one is to enable huge pages in your hypervisor. Sometimes you have to consider the NUMA scheduling, so to allocate the virtual machines and memory pages in the same NUMA nodes to get performance. And if you need to do PCI pass-through because you really need performance and you want to give the virtual machine access to the real hardware, this is now fully supported in SIMS 502. When you create a virtual machine that is going to use PCI pass-through, when you go to the interfaces, let me just create quickly a new one. When you go to the network and you attach, for example, to one of the virtual networks, and you want this virtual machine to have attach a network interface from the hypervisor, you have to enable that. In hardware, you say this is going to be a PCI pass-through interface, and you need to select the hardware element that you want to do PCI pass-through. This is obtaining from the probes, the monitoring probes. So if you are going to use this, you have to select which interfaces are going to be exposed for PCI pass-through, right? So in this case, I'm going to take this Ethernet card, and that's it. So what is interesting is if you instantiate this, I'm not going to do this, but so when you create a virtual machine which is attached to more than one PCI pass-through, you have to identify which hardware interface is attached to a given virtual network. Because when you're doing pass-through, from the hypervisor, you basically lose control of the device. So to some extent, you cannot change the MAC addresses because you don't see the interface in the hypervisor. So how do you identify from the host which interface is really the one associated to a given network in order to configure the interface or to set up the IP? What we've done is to use the PCI addresses for the interface. So if you take a look, where it is, just a second, which is here. didn't pick an interface, right? Sorry, I forgot to. Pick a network. Okay. So, in order to identify the interface, what we do is to fix the PCI address of the network card in the guest. So, in this case, the virtual network card is going to be attached to address 11 in the guest. So, knowing the PCI address of the interface, I know that that network card has to be attached to this IP network with this MAC address, so I can configure that. So note that you are not able to do that from outside because from the hypervisor you don't have address to this network card, and you have to do it through the guest. Okay. Any question? Okay, so let's move on quickly to the next slide, which is our security groups. Security groups are, as you probably know, used to filter traffic. So I just wanted to show you how this is implemented in OpenNebula. In OpenNebula, we have a special rule to route the traffic when it's breached. So when the traffic goes through a breach, it's redirected to the OpenNebula chain. And in the OpenNebula chains, we have an outbound, or an inbound rule for each VM. And the rules that you impose in your security groups are implemented in these outbound or inbound chains for the VM. So when you filter, for example, or only allow the SSH traffic, what we do is that match the SSH traffic here, and by default we are dropping any other traffic. So in the security group, you define the traffic that the VM is allowed to send or receive. Okay? So I think I don't have time to make you a brief demo of this, and we can go for. Okay, I have the IP address management. Sorry for that. Okay, briefly enough, this was an awesome contribution from Christophe and Guillaume. They implemented all this IP address management part. They write the first drivers and the core part. And the idea, as I said, is to delegate IP address management to an external component. So in 5.2, you have three options. Or two options. Use the built-in mode where OpenNebula manages your IPs, or develop a custom driver to interact with your IP management software. So the operations are pretty simple. You have the register address range, which is used to communicate with the IP address manager you are creating a new virtual network in case you need that, or in case you want the IP address manager to give you the network. And every time you create a virtual machine, the driver is invoked. So for example, when you say, I want a virtual machine or 5 addresses from this range, you go to the, or you need 5 addresses, you go to the allocate or the get address scripts, and you get which addresses are going to be used in OpenNebula for the VM. And from there, OpenNebula will use this IP as any other, or as if the IP was get from a regular OpenNebula network. Okay, so I have here a space because I don't know if Guillaume is here. Yep. And because he's going to explain his integration